Hello, everybody. Today is Wednesday. Yeah, it's Wednesday, right? Yeah, it's Wednesday, the 15th of October, and we are halfway through our week 9. I'm Yeah, let's just move on with this. Just a little bit of housekeeping. If you are one of the people that were still making up work that you had talked to me about, please get into that right away. If you had sent me something, you should have seen something come back to you by now, or you should have seen the changes, sorry, made that you were referencing. So I did know some people had some that were out of town or out that had some extensions on some things. If you did get an extension on thing, please get that done as soon as possible, just so we can make sure you stay in on track. All right, let's go into the module because I want to show you what you have going on for today. So let's go ahead and go ahead and share. All right, here is our module. And we are down in, Hey, everybody. We are down in week 9. Now, you should see the lithosphere discussion should be opening up. If not at this moment, they should be opened up very, very soon. The discussion shifted a little bit than from what you're used to. In here, we are actually starting to get more prompts. As we go along, there'll be more and more things for you to choose and pick from in your prompts. All right, hold on one second. I need to do this one. All right, so here we go into here. As you can see, like there'll be more prompts, more availability for you to make your own selections. And then we got 3 articles here, plus we have the Geologic Survey latest earthquake map. This is a fun one. This shows you all the latest maps. And actually, we did have a new one that happened today. This is while I was actually in my in-person class. We actually had a brand new earthquake happen while I was in class, and we've been watching this. So this one happened in Manatee, California. It was at a depth of 10.2 kilometers. So that is the focus, where it happened in the earth. The epicenter is this location, 9 kilometers west-southwest of Manatee, California. So this exact coordinate is the epicenter. The depth below it is the focus. So keep that in mind. Take a look around. See, there's lots of earthquakes going on, and these are only the magnitude 2.5 and above. If you go smaller than that, you become overwhelmed with the sheer number of them. But as you'd expect, most of these earthquakes are taking place somewhere near fault lines. So that's kind of a cool thing. All right, let's get back into our talk document. Some of these other things are this is about the worst earthquake ever recorded, happened in the 1500s, and the sheer amount of people, like 800,000, sorry, over 800,000 people died. That is crazy. And then this one's about designing buildings to withstand earthquakes. Now, I've been in all sorts of natural disasters and things, and one thing I don't like is earthquakes because I don't think the ground should be moving. But that's just me. So again, this is about things you can do, and here is just a standard safety checklist for earthquakes. Are you familiar with these? Most of us in this area are not, so it's a great thing to take a look at and gain some information in. All right, so that is that. Next, what's coming up is the climate lab. There is a lot going on in this lab. There will be multiple videos available for you to look at in this lab. Please take the time and watch those videos before you jump in. It will save you a lot of hassle, and it'll save me from having to go back and fix a bunch of errors that people made and did not have a chance to fix themselves. So watch that. If you go in, you will see the master walkthrough. You will also have a couple sub walkthroughs. It's like we have the Koppen-Geiger flow charts here. Please take the time to watch the video on these. These are kind of confusing. They are dichotomous keys, so every question, everything has a yes or no answer. That's it. So take your time to read through these. Here we have some areas we're trying to figure out what the Koppen classification is for that. You will use these flow charts up there to find these. So go ahead, take a look at these. Then we're going to get down to the climate change form. We know, well, according to the IPCC, we are in store for some serious changes in our climate. One of them being 5 degrees warmer Fahrenheit and 10% drier by the end of this century. So I want you to go ahead and take this information and you're going to start making a table. This table actually is just there so you can calculate this. You can put your new temperature and your new precipitation in and make your averages here at the end. So you will be using that in the assignment more. All right, let's go back in here. So once you're done with that assignment, drop it into here. Then using that information, find your average new annual temperature and your annual total precipitation. Now, using these new factors and your new chart, what would Rochford's climate code be in 2100 at the time when all of these factors are in play? Moving on. The next thing is, how can we shift Rockford's environment to change our classification? If we wanted to move Rockford into a C or a warm weather climate or a mild mid latitudes, we would have to raise its temperature. How do we find that out? By looking at our chart here and finding out what is the minimum threshold to be considered a C, and C's are in here. So how do we get to this minimum threshold? For it to be considered a C class, every temperature must be greater than or equal to 26.6 degrees. Using our charts, how much does it have to change if you take your information and run it right into your shirt? I mean, to your teacher in there. So you want to, sorry, la, 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 la. Yeah, you're gonna run this right in, do this. Okay, so we find what we had before. And then in order to get to the C, we have to say we need to be at 26.6. What can we do to change that? Okay, so that's that one. The next one is, how do we change this from our current climate into a desert climate or a deficit climate? And here we're dealing with our annual average precipitation. How much less rain, how much drier would we have to be to get into our B climate? And in this one, we are using these charts here. So we figure out what is our precipitation. Are we all year precipitation, winter precipitation, or summer precipitation? And then you take the current temperature and you trace it along the grid here. You take your current temperature, trace it along the grid, find out where it meets the rain line. Where is that rain line that it has to be? And then you can take where that rain line is and where our temperature is and subtract the rain line from our actual precipitation, and that will show you what the change has to be. And you're taking our mean annual precipitation to find that out. All right, it's moving through here. And then the last project is our Route 66, the Mother Road project. If you did not know, Route 66, or the traditional path of Route 66, ran all the way from Chicago to the LA metropolitan area. More importantly, it goes from about Rainbow Beach in Chicago all the way to Santa Monica Pier in California. So it goes from water to water, the Great Lakes to the ocean. So, a cool thing about our country is we are very vast and diverse. And one of those things that is very diverse on our continent is the temperature range. I mean, the climate zones. Between here and LA, you will pass through 9 different defined and named climate zones. Your task for this is to locate these locations and then figure out what climate zone they are in. You will then put your answers into here and submit that. So like the first one, Chicago, we should know Chicago is here. Using the downloaded folder or the files, or even this little pop-up map here, we can identify what is the classification around Chicago. And we actually see that right here. So for here, you would go on to the number one, Chicago, and you would put DFA. Now for your place mark, you now need to go back up here and figure out what is that classification. So in our classifications, this chart's right here. We need to know what is a DFA. Okay, here we go. A DFA is a humid continental. It's a humid with severe weather, no dry season, summer or fall or winter. All right. So you will do that with each one of these cities. And each one of these cities should be different than every other city. If not, there's a problem. Okay, once you're done with that, go ahead and put those together and then submit them for your final project submission. All right, everybody, that should be everything here for you. Let's go ahead and stop my share. All right, that can be a very complicated lab. Make sure if you're having troubles, look at those videos. If you're still having troubles after the videos, send me a message and I will make something up new for you. All right, everybody, have a great day. Enjoy. Bye-bye.